Hello everyone, welcome to this session and let us start new episode of Let's Get Solving with Google Cloud. So my name is Meenal Borkar and I work as instructor for Google Cloud platform. So today our topic is building machine learning models without writing code. Now I can see a frown on your face. Like, is it really possible? Answer is yes. With Google's technologies and its collaboration with Google Brain's team, it is very much possible to build your machine learning models without writing code on Google Cloud Platform. So let us see how this can be done. So the product that we are going to talk today is called as AutoML. So in short, if you want to remember what is AutoML, it is a product which will enable you to build your custom models without writing codes. So what basically you do here, you upload your data set for your machine learning model to train. Then that data set you basically apply labels, and then AutoML will automatically create a machine learning model internally for your data, and then you can use this trained model to evaluate your model, to test your model, and further you can use it as your deployment model. Okay, now this particular AutoML product is very much suitable for people who want to use or who want to utilize advantages of pre-trained models and bit want to apply bit customization over these pre-trained models. So we are going to take one example during our lab session and I will be talking about that. So under AutoML we offer three products. First product is called as AutoML Vision. So basically it is used for image analytics purpose. So you upload all your images with labels, customized labels, and then the model will predict the customized label out of your data set. Second model is AutoML natural language processing. So as the name suggests, this is suitable for the text-based data. And then the next model is AutoML tables. So in this particular activity we are going to consider AutoML Vision, in which without writing code we will classify different types of clouds using scientific terms. So let me talk a bit about a simple process that typically AutoML follows to train, deploy, and serve your machine learning model. So the first step is training your model, and when you actually train your model, you need to basically prepare data set. Now, what you typically do, you upload all your data files. In our case, those are image files. So we'll upload them into our Google Cloud bucket. Then we will create a CSV file, and in that CSV file we will mention path to that image file and the possible guidance or label that is associated with that image. Then we will upload this model, this data set into our AutoML UI, and then the data set gets imported. Then training phase starts, and during training phase AutoML automatically performs data exploration, readiness, and other things. Then it trains the model internally, so it automatically generates best possible configuration using which the best evaluation and best prediction can happen. Then after training is done, it internally tests and evaluates the generated model. Once the model is available, you can then deploy this model to so that the model becomes available for people to use. And then just by using JSON request and reply format, your customers can predict or classify different objectives out of this AutoML model. So that is a very brief and very simple overview about AutoML. Now, just like other sessions, today also we are going to have a lab activity on Qwiklabs platform, and I'm sure we all know now that Qwiklabs is our hands-on lab portal, and it gives us access to nearly 500 plus labs which we can start. So please note down the link for this particular session. Also scan the QR code which is displayed here. Once you click on this particular link, your lab page will open, which I'm going to show you in a minute. And you know the steps very well. Once you go to that page, sign in if you have already registered with Qwiklabs portal, or join if you want to, if you want to, if you want to join Qwiklabs if you haven't created your account yet. Now there are certain standard steps that you need to follow in order to run your lab. So first you will see a green button called as Start Lab. So once you click on that Start Lab button, you typically get temporary credentials generated by Qwiklabs platform, username and password. And typically these usernames look like student hyphen something something at qwiklabs.net and other stuff. Then in an incognito mode, you open your Google Cloud console, you sign in using these credentials, you set your project ID, and then you follow the activities which are given in your lab. So do note down this link as well as scan this QR code. And there is an exciting offer associated with this particular activity. So once you finish the lab activity which is given for this session, you will typically unlock your 1 month's free subscription on Qwiklabs portal. And then if you complete the allocated quest or your homework activity, you can also get additional credits deposited into your account. So do note down this link as well as this QR code. Now let us start talking about the lab activity that we are going to perform in this lab. So the activity is classifying images of clouds in the cloud using AutoML vision. Now there is a word cloud which is coming twice. So let me talk a bit about what actually this activity is. So you need to imagine with me like I am a meteorologist and I'm working on classification of different shapes of clouds to predict what kind of weather pattern I'm expecting particularly. Okay, so what I typically do, basically I collected various cloud images, and then I tried analyzing those images using Vision API. But then Vision API being the pre-trained model, it returned me labels like, there is a sky, light blue color, some clouds and other stuff. But being a meteorologist, I'm typically looking for classification in terms of cloud shapes or cloud patterns. So typically the cloud patterns which meteorologists use are called as cumulonimbus or cirrus, and typically these patterns, they determine what kind of weather you can predict over a coming period. So that is our activity. Now see the challenge here. Vision API is able to detect that there are clouds in this image, there is a sky in this image, but it is not giving me answer in terms of cumulonimbus or cirrus or whatever with that specific terms or specific jargon. Now this little customization I'm going to apply using AutoML, and that is the crux of this lab. Okay, so let me share my lab manual with you. This lab is kind of typically 50 to 60 minutes activity. So I have already started the lab and I have done some preparation behind scenes so that we can discuss different parameters during the discussion. Okay, so let me share my lab screen with you all. Just give me a second for that. So I hope you can see the lab manual, which says classify images of clouds in the cloud with AutoML vision. Now if we scroll down, there are certain activities which we need to perform as a part of setup and other stuff, and I'm going to show you all these activities one by one. So the first thing that we need to do here is we should perform setup our AutoML vision. Then we will upload training images to cloud storage. Then we will create a data set. we will upload this data set and we will see what kind of images are uploaded. Then we'll train our model, we'll evaluate our model, we'll see different parameters there, and then we will quickly perform prediction in this lab. Okay, so let me take you to my cloud console, where I have already started the lab. So I will quickly walk you through different aspects there. So just give me a second while I share that screen with you. Okay, so I hope you can see my screen, and let me zoom in a bit so that you can see it properly. Okay, so this is my standard landing page of Google Cloud Platform, and the first activity which I performed here is enabling AutoML Vision API. Now GCP is API driven platform, so all the products you basically have an API that is actually responsible for performing actions. So in order to enable that API, I'm going to navigation menu, then I'm going to APIs and services, and then I'll go to library. Now here I will simply type AutoML. Sorry, so something wrong happened here. So we are going to APIs and then we'll go to library. Now here I will just search for AutoML, and you typically get two APIs listed here, Cloud AutoML API. So you need to click on this Cloud AutoML API result, and then I am seeing manage here because I have enabled this API as a part of preparation for this this particular session. But you will see an enable button here, and you need to click on that. As I already clicked on that enable button, my API is enabled, and I can start working with it. Now the next step that we need to perform is we need to first prepare our data set, and we need to upload our data set onto our Cloud AutoML API. Now for that purpose we are going to use Cloud Shell, and as you all know, Cloud Shell can be activated using this particular symbol which is available here. All right, so let me just open this particular Cloud Shell. Now first thing, there are a couple of steps in the lab manual which basically ask us to prepare certain environment variables, and that we did by using this particular command. So the first command that I used, I created a project ID variable, and I passed my Qwiklabs project ID, which is shown here in yellow color, into this variable. Next, what I did was I created another variable called as Qwiklabs username, and I passed the username which is generated by my lab manual into it, because I'm going to enable this particular user to work with my project under AutoML activity. Then the next command, I basically created a policy which says the member using whose username is this student hyphen something something at qwiklabs.com should have AutoML admin kinds of rights, and that activity I have performed using this particular command. So I used gcloud command, and then I added a new role which you can see here in the highlighted section as AutoML admin. So this gives me full flexibility to work with my AutoML project. Next setup action that we need to perform is we need to create a bucket, a cloud storage bucket, in which we can actually upload our images for training purpose, and we will also create dataset CSV file that will be also stored in this bucket. So as you can see here on the screen, I used gsutil mb, that is make bucket command, and I created a bucket called as project id -vcm. So let us check whether this bucket is created in my storage service. So for that purpose, now I'm going to navigation menu, and in the navigation menu, then I'm going to storage section. I will go to storage service and I'll then click on browser. So basically here I should see a bucket created called as my project followed by VCM, and you can see here the bucket is readily available. Now once the bucket is available, our next task is we should copy our cloud images to this bucket, and for that purpose I use this command gsutil cp, which says I'm copying, and all these cloud images are already available in a public bucket called as AutoML Qwiklabs, and from that bucket I'm copying it to my bucket. So I copied all those files, and typically there are 60 files available. Then I copied data CSV to my virtual machine, which is this Cloud Shell window. And once I do that, then I basically checked different labels in this data CSV. Now what we are going to do is, let us check how exactly our data set looks like. So let me use simple ls command here just to check whether data.csv exists. So we can see data.csv is there, and then I can say simply head first 10 lines. So I want to display first 10 lines of this data.csv. So see here how exactly we have created this data set. So see this highlighted entry here. The first part before comma indicates the path to the first image of your data set. So here we are saying that this is my bucket and this is the folder under which this 1.jpg is uploaded, and then for this image we have given a sample guidance to our AutoML model, saying that hey, the cloud shape that you have here is actually a Cyrus form. Okay, so this is the label, this is the guidance that we are providing to our model so that it can get trained. So you may write here like Cyrus or cumulonimbus, and that is what we have prepared. Now that is what I wanted to show you. Once this data file is created, then we actually copied this file to our cloud storage bucket. So again we are using gsutil cp command, and we copied this data.csv into my bucket. So as effect of all these copy operations, my bucket should now show certain folders which contains actual images, and then a data.csv file which gives me paths to the file, and then the label associated with that file. So let us check whether all those contents are available in my bucket. So I'm going to click on my bucket name here, and then see here there is a folder for images which contains Cyrus images. There is a folder for cumulonimbus cloud patterns, and then cumulus pattern also. And you can see data.csv also here in which we have created path to all these images and the associated label. All right, so that preparation part is pretty well covered here. Now the next step is we should create AutoML data set, so that we should upload this data.csv so that training can start, and then we can take this further. All right, so for that activity, let us go to navigation menu and then scroll down to the AI section of offerings. Under AI section, you can see here variety of services are available, and we are going to use a service called as Vision. So I am just clicking on Vision here, and you should see what offerings are available under Vision offerings. So you have Vision API, you also have AutoML Vision given here. So our task is to work with AutoML Vision. So let's click on Get Started. Now let me show you the next step, in which the first step is we need to create a data set. So for that purpose, click on new dataset. It will ask you to give a name. So let me specify the name as clouds 1. Then here for any image, we want to just predict whether it is cirrus or cumulonimbus or cumulus. So it is a single label classification that we are going to perform. So I have selected single label classification, and then I will simply click on create dataset. Okay, now when I click on creating this dataset, it will actually give me a facility using which I can either upload images directly from my computer, but in my case I have created a CSV file where path to the image with the label is given. So I'm going to use this option. So I'll select CSV file, then I will scroll down, and then by using this browse option I will go to my bucket, and then I'll select this data.csv for my data preparation action. Now once I select this file, you can see the continue button is enabled now. When I click on this continue button, my AutoML will start reading all the images from my cloud storage bucket and will start assigning the label given in the file to that image. Typically this process takes 3 to 5 minutes to complete. So to save time, I have already created a data set. So let me show you that data set directly. So you can see I have already created a clouds data set, and it contains 60 images, and all 60 images are labeled for this activity. So let me click on this data set to show you how exactly images and labels look like. So this is the window that you typically get when you work with AutoML images. Now you can see image statistics here. So all images 60, all 60 images are labeled. In case there is an image which is not labeled, you can see here under unlabeled. And then if you want to see labels distribution, you can check it here. So we can see there are 20 images for cirrus, 20 images for cumulonimbus, and 20 images for cumulus. If you go to right hand side, you can see different photographs and their associated label. So you can see these types of clouds, they are called as cumulonimbus, and these types of clouds are cumulonimbus, these are cumulus, and these are cirrus, and something like that. Okay, now what if I want to change label of a particular image? Can I do that? Answer is yes. Just click on this image. Now the image will get enlarged, and then if I want to change the label, I can do that here in this left hand side panel. Okay, so I can very well do that, but for this activity I don't want to do that, so I will just say cancel. And then the next activity that we need to perform is we need to train this model. Now what happened during the training? So my AutoML vision will check all these images along with their labels, and then we'll try to come up with some understanding. So I'm going to training phase. Then we need to click on train new model. Typically whatever model name it gives, we do not change the parameters. In the second step, under set a node hour budget, it is recommended to set your budget as 8 nodes per hours, and then you can start training. Now typically this training will take 20 to 30 minutes to finish the activity. Now to save the time, I have already trained a model before this session, and I'm going to talk about this model that is already trained. Now how will I determine whether my model is working properly? Is it accurate? It is giving me required results. Okay, so see here, I got certain parameters which are associated with this model, and it says precision of my model is 0.92. So 92% is the precision, or my model is precise in identifying different products, different labels which are associated with the images. So it seems it is a fair model, and then I will check the evaluate tab, because AutoML will train your model and then automatically evaluates it for internally for checking whether your model is working properly or not. So let us click on evaluate. Now under evaluation, you will see how exactly your model has worked. So it says it tested your model on 54 images. It tested on 6 images internally, and it says that 83% times the answer was correct. So it seems to be a good matrix, good model to start with. If you know machine learning terms more, then you may scroll further down to find out confusion matrix and other parameters which are associated with our model. All right, the next activity that we need to perform is test and use. So basically, test and use tab will enable us in generating deployment of this trained model so that our customers can use it. Now typical deployment activity takes 15 to 20 minutes. So I have already created deployment for this particular model, and using that model, now I'm going to perform a prediction or classification for my model. So if I scroll further, there is a test your model section available, wherein I can upload my image. So I can upload up to 10 images at a time, and for all those 10 images I can get the label detected, whether it is cirrus, whether it is cumulonimbus, or whether it is cumulus. So let me click on upload images, and then a dialog box will appear in which I need to basically select the photograph for upload purpose. Okay, so let me just upload one image for you. All right, so here in the download section, I have just got one image downloaded. So let me just download it again. It seemed it wasn't downloaded properly. Okay, let me check that. All right, so all right, so now I have 3 images with me for testing purpose. So you can see these 3 images, test JPG and then the sample JPGs. I'm going to select all these 3 and then I'll click on open. Now see the images which I have uploaded here. This is my first image, this is the second image, and this is the third image. And then I got a prediction from my model. So for the first model, I got the prediction of cumulonimbus, and my model is 68% confident that this label is true. For second model, it is 100% confident that this has to be cumulonimbus. And for third image, it gave me Cyrus as the label, and it is 99% confident that the classification is done properly. So this is how you basically test and use your AutoML vision model. Isn't that awesome? Like, we just created one AutoML model, one machine learning model, without writing a single line of code actually. So that is all for this particular session. So before taking a wrap up, let us take a quick summary, and just give me a second while I share the summary screen with you all. So okay, so I hope you can see my screen, and let me talk about this. So basically, what is Cloud AutoML? So basically, you can train high quality custom machine learning models with minimum efforts and machine learning expertise. So anybody can use this model. It is suitable for your custom machine learning models, and basically it uses Google's state-of-the-art transfer learning and neural architecture search technology behind scene. It is very fast. Internally, we have tested more than 10 years our research technologies before offering this as a service. It is very fast, and it can generate high quality training data. What all AutoML products do we offer? So we have AutoML Vision, and AutoML Video Intelligence is currently in beta. So these are for your image analytics and video analytics. We offer AutoML Natural Language and AutoML Translation for your text-based activities. And if you want to perform structured data-based activities, then AutoML Tables is also available. If you want to see more about our customers, then here is one customer case study from Disney. So you can see this particular highlighted section. So AutoML has helped Disney to build vision models to annotate their products with Disney characters and categories and colors. And basically, initially, it was taking very much time for Disney to do all these activities. But with AutoML, the labeling has done properly and quickly now. And now the model is also performing product recommendation on Disney Shop. So if you are more interested, do visit this page, and then there are more case studies available. So that is all from my side for this session. Thank you so much for being with me, and I hope you already enjoyed this particular session. And I encourage all of you to take this lab and test how our AutoML product is working. So wish you all the best, and again reminding you, do complete this lab to avail the subscription offer that is given to you. So thank you so much for being with